Study.
Hello guys, welcome back to Study Buddies. Today, we will continue with part 2 of linear momentum. In this lesson, we will learn about conservation of linear momentum. The first part of this lesson is Principle of Conservation of Momentum. This principle states that in an isolated system, the total linear momentum is conserved. When I say isolated system, it means no external force is acting on that system. This principle is applied during explosion and collision. However, in this lesson, we're going to learn about collision only. There's 3 types of collisions, which are elastic collision, inelastic collision, and perfectly inelastic collision. Take a note guys, actual collision usually falls between elastic and perfectly inelastic collision. Let's look at first type of collision, which is elastic collision. For elastic collision, both momentum and kinetic energy are conserved. It means the total momentum and kinetic energy before and after the collision are the same. The equation of conservation of momentum is m1u1 plus m2u2 equals to m1v1 plus m2v2, while the equation of conservation of kinetic energy is half m1u1 square plus half m2u2 square equals to half m1v1 square plus half m2v2 square. m1 is mass of first object, m2 is mass of second object. U1 is initial velocity of first object. U2 is initial velocity of second object. V1 and V2 are final velocity of first and second object respectively. Moving on to inelastic collision. In this collision, only momentum is conserved and not kinetic energy. Since the kinetic energy is not conserved, the total kinetic energy before the collision would be bigger than total kinetic energy after the collision. This is because during the collision, some of the kinetic energy is lost and converted to other types of energy such as sound energy, heat energy, and work to deform an object. The equation of momentum is similar to elastic collision as momentum is conserved in both the collision. As for kinetic energy, the equation is half m1u1 square plus half m2u2 square is greater than half m1v1 square plus half m2v2 square. As mentioned just now, the kinetic energy before collision is greater than the kinetic energy after collision due to the transformation of energy. Next, we will learn about perfectly inelastic collision. So you might be wondering what is the difference between inelastic and perfectly inelastic collision. Alright, perfectly inelastic collision occurs when the objects stick together after the collision, while inelastic collision, the objects does not stick together. Since the objects stick together, the final velocity of the objects involved in this type of collision would be the same. The equation of conservation of momentum is m1u1 plus m2u2 equals to m1 plus m2 times v, while the equation of kinetic energy is half m1u1 square plus half m2u2 square is greater than half m1 plus m2 times v square. These equations are more or less the same as inelastic collision. The only difference is perfectly inelastic collision has only one final velocity, while inelastic collision has more than one. As mentioned just now, the kinetic energy before collision is greater than the kinetic energy after the collision due to the transformation of energy into another form of energy, such as sound, heat, and work to deform an object. Let's have a look at a sample question before we end today's lesson. A 1500 kg truck traveling eastward at 15 meters per second rear-ends a 1200 kg car that was stopped at a red light. The collision caused both vehicles to stick together. What is the final momentum of the vehicles? Okay, in order to solve this, we have to know what type of collision this is. The keyword of this question is stick together. Based on what we have learned just now, only in perfectly inelastic collision, the objects will stick together. Therefore, it's clear that this is a perfectly inelastic collision. We know that the total momentum before the collision is equal to the total momentum after the collision, as momentum is conserved in perfectly inelastic collision. Now, expand the momentum's formula, and this will give you the equation m1u1 plus m2u2 equals to m1 plus m2 times v. Substitute the values into the equation and find the value of v. Since we know the value of final velocity, we can now find the final momentum of the vehicles. Use the formula P equals to m1 plus m2 times v. Substitute the values and solve it. The final momentum of the vehicles is 15,012 Newton per second. 15,012 Newton second. You guys might have a doubt on why we don't use kinetic energy's formula instead of momentum. The reason why we use momentum's formula and not kinetic energy is because momentum will give us more accurate answer compared to kinetic energy, which will only give us range. This is because kinetic energy's equation has an inequality symbol, which is a greater than symbol. So that is all for today. Thank you for watching, guys. Hope you all enjoyed today's lesson. Don't forget to like, subscribe, and click on the bell icon down there. See y'all in the next lesson. Bye!